This video is on creating systems in context. So we have been working with systems of equations, and it might not be obvious when do we actually use these. So these word problems give us some realistic examples of when we might use them. They're really useful when you have situations where you have a number of different specifications you want to meet. For example, if I want to buy a certain amount of two different items and spend less than a certain amount. Systems of equations are really helpful letting me know how much of each item I could buy, even though they're different prices. So let's look at some examples today. We're going to look through two examples. The first thing I would encourage people to do is read carefully. So these are word problems, and the more you do of these types of word problems, the better you get at them. But you do have to be careful because it is easy to miss important details. The second thing we're going to do is identify variables. In all of these problems, your variables are going to be explained down here. And so we'll kind of have a look at those and figure out what are our variables. And then the last thing they're saying is make sure the units make sense with the equation. So when we finally kind of create an equation, which we'll do in a minute, we have to check and make sure, do our units make sense? Will our units work out? This is a really great way to check if we are incorrect or correct. So let's jump right in. We have Courtney walked from her house to the beach at a constant speed of 4 kilometers per hour. So that seems like an important detail, maybe. 4 kilometers per hour. And then walked from the beach to the park at a constant speed of 5 kilometers per hour. So that seems pretty important too. And then finally, they tell us the entire walk took 2 hours, and the total distance Courtney walked was 8 kilometers. Okay. So they say, let B be the number of hours it took Courtney to walk from her house. Okay. And P be the number of hours it took her to walk from the beach to the park. So this first section is from the house to the beach, and the second P is for hours it took her from the beach to the park. Okay, so this is a lot of information thrown at us at once, and we kind of need to figure out, well, how can I slowly isolate this? Well, the first thing I notice is when I have these 4 kilometers per hour, that is a constant speed, and that's when she's walking from the beach to the park. Beach to the park. They also mentioned beach to the park down here. So down here it says this is the number for the beach to the park, and I need to correct myself. Beach to the park is actually referring to this 5 kilometers here. Read carefully, unlike me. So beach to the park is going to be 5 kilometers per hour. This P is going to be somehow connected to that because that's also from the beach to the park. And so we're going to say P is somehow connected to this value here. And similarly, we can say that this 4 kilometers is between her house and the beach. And so this is between her house and the beach. And so B is somehow going to be connected to this 4 kilometers per hour. And so when I look at this, I am thinking that the total kilometers she walked is going to be 8. And so if I say she ends up walking 8 kilometers, and 8 is going to be a combination of two things. It's going to be the kilometers she walked between her house and the beach, and it's going to be added to that the kilometers she walked from the beach to the park. So if we are thinking about this, well, how many kilometers did she walk from her house to the beach? They tell us how fast she went, but they didn't tell us how many kilometers she went. Well, we could actually figure that out because we have kilometers per hour. So how would we get kilometers? Well, we would have to multiply by time, and B is our time. That's the number of hours. So if I do the number of hours, B, times 4 kilometers per hour, I would get kilometers per hour times hours would give me nothing, which is what I want over here. Similarly, if I do 5 kilometers per hour, well, that doesn't tell us the distance she walked, but to find the distance, how long did she walk 5 kilometers per hour? Well, she did that for, it says P hours. That's the number of hours it took her to walk from the beach to the park. So we're actually going to say for this other one, we're going to say this is going to be 5 times P. So 4 times B plus 5 times P equals 8. And just checking our units really quickly, this makes sense. So this works. So we're given 4 options. So let's see if this works with any of our 4 options. So I'm seeing 4P and 5B. That's actually not what I have. It's close, but this doesn't make sense, so I don't really like that. 4B, 5P. I'm seeing 4B, 5B down here, but it's saying equals 2, and that's not correct, right? Because it should equal 8, we said. So I like this option D down here. All right, so let's just kind of double check and let's see if we can make sense of anything else. So they're saying some other thing, B plus P equals 2. Well, so what they're saying is the number of hours it took her to walk from her house to the beach, that's B, plus the number of hours it took her to walk from the beach to the park equals 2. So they're saying that her whole trip took 2 hours, and it's telling us here the entire walk took 2 hours. So it looks like this is also a correct option. So both of these equations seem to be correct, and so we're going to go with D. D is the correct answer in this case. As you guys can probably tell, these problems are a little bit involved. They take some time, they take some practice. That's okay, you might not get everything your first time through on these problems. Just do it again. Take some notes, pay attention, make sure to use the hint option on those. Look at some of the other videos on Khan. And let's look at one more example right now together. So if I get rid of this stuff, let's scroll down. Okay. So this is interesting. They're telling us Fred is 4 times as old as Nathan and is also 27 years older than Nathan. Okay, so maybe I'm thinking like Fred and Nathan. Okay, let F be Fred's age. So we have one variable is F for Fred's age, and the other variable is N for Nathan's age. They want to know which system of equations represents this situation. So the first thing I'm going to think about is just this first sentence. Fred is 4 times as old as Nathan. So I'm just thinking about this. So if Fred is 4 times as old as Nathan, then F, Fred's age, should be 4 times whatever Nathan's age is. So I could say F equals 4 times N. So if this is Fred's age, I know it should be 4 times as big as N. And this equation expresses that. This says F is 4 times N. This is 4 times as much as N, right? Because when we have our coefficient, that means multiplication. All right. And so I see F equals 4N, F equals 4N. This N equals 4F, that doesn't look right. 4F equals N also does not look right to me. So we're stuck between these two, and they give us a second equation here. And that has to do with the second part. So we also say Fred is 27 years older than Nathan. So Fred is 27 years older than Nathan. Another way of saying that is I could say that Fred's age is Nathan's age. Whoa. Let me delete that. Oh my gosh. Excuse me, guys, I accidentally created an empty folder. All right. So Fred's age, we were saying, is 27 years older than Nathan's age. And so we have Nathan's age here. And the question is, should this be plus 27, like we have down here, or should it be minus 27, like we have over here? And let's just imagine, let's say I put plus 27. Does this make sense? Should Fred's age be bigger than Nathan's age? Yes, that makes sense. Imagine if we had done the other thing. Imagine if I said Fred's age equals Nathan's age minus 27. We know Fred is 4 times as old as Nathan. We know Fred is older than Nathan. So saying Fred's age is Nathan's age minus 27 years doesn't really make sense. This would mean, like, for example, if Fred was 50, then Nathan would have to be 77 to make this equation true. And that doesn't make sense. because we know that Nathan is 4 times as old as Fred. And so this last equation really does not work. So if I just get rid of that for a second, that means we are going to choose as our final answer this one down here. We like this one. So B is going to be our final answer. Again, these are kind of tough problems. They take a little bit of time to kind of figure out. But the reason these are so powerful is, check this out. Let's say I actually wanted to figure out what Fred's age was. I can do that. So if I say f equals n plus 27, I can rewrite this equation up here. And I can replace f with n plus 27, and you might even, for fun, try that. But that's not really part of this homework yet, so we're going to leave that for later on. I just wanted to give you guys some motivation for why we're doing these tough types of word problems.